Astronomers find a giant hiding in the fog around a young star. Astronomers have detected a giant exoplanet between 3 and 10 times the size of Jupiter, hiding in the swirling disk of gas and dust surrounding a young star. Earlier observations of this star, called MP-MUS, suggested that it was all alone without any planets in orbit around it, surrounded by a featureless cloud of gas and dust. And the European Space Agency's Gaia mission suggests that the star is not alone after all. However, a second look at MP-MUS, using a combination of results from the Atacama Large Millimeter-Submillimeter Array, the international team of astronomers, led by the University of Cambridge, detected a large gas giant in the star's protoplanetary disk. The pancake-like cloud of gases, dust, and ice, where the process of planet formation begins. This is the first time that Gaia has detected an exoplanet within a protoplanetary disk. To date, only 3 robust detections of young planets in a protoplanetary disk have been made. Its surrounding disk showed none of the gaps where planets might be forming, and was completely flat and featureless. The results, reported in the journal Nature Astronomy, suggest that similar methods could be useful in the hunt for young planets around other stars. But this seemed odd to us, since the disk is between 7 and 10 million years old. In a disk of that age, we would expect to see some evidence of planet formation. Using data from Gaia, he found MP-MUS was wobbling. Sign up for our free newsletter and get updates on breakthroughs, innovations, and research that matter daily or weekly. By studying how planets form in the protoplanetary disks around young stars, researchers can learn more about how our own solar system evolved. I was revising my calculations when I saw Alvaro give a talk presenting preliminary results of a newly discovered inner cavity in the disk, which meant the wobbling I was detecting was real and had a good chance of being caused by a forming planet. And using the longer ALMA wavelengths allowed us to see structures we couldn't see before. It also means that many more hidden planets might exist in other disks, just waiting to be found. Once again using ALMA, they observed the star at the 3 millimeters range, a longer wavelength than the earlier observations, allowing them to probe deeper into the disk. Because in this case, we needed the ALMA and Gaia data together, said Ribas. The longer ALMA wavelength is incredibly useful, but to observe at this wavelength requires more time on the telescope. We first observed this star at the time when we learned that most disks have rings and gaps, may be used to look deeper into more disks and better understand the hidden population of young planets, which could, in turn, help us learn how our own planet may have formed. And I was hoping to find features around MP-MUS that could hint at the presence of a planet or planets, he said. Through a process known as core accretion, gravity causes particles in the disk to stick to each other, eventually forming larger solid bodies like asteroids or planets. doi 10.1038 SPAR 1550025025776W. As young planets form, they start to carve gaps in the disk, like grooves on a vinyl record. However, observing these young planets is extremely challenging. Due to the interference from the gas and dust in the disk, Dr. Alvaro Ribas, from Cambridge's Institute of Astronomy, who led the research, specializes in studying protoplanetary disks. The researchers say the wobbling is likely caused by a gas giant less than 10 times the mass of Jupiter, orbiting the star at a distance between 1 and 3 times the distance of Earth to the Sun. Using ALMA, Ribas observed the protoplanetary disk around MP-MUS in 2023. The results showed a young star seemingly all alone in the universe. Our earlier observations showed a boring flat disk, said Ribas. Now, Ribas and his colleagues from Germany, Chile, and France have given MP-MUS another chance. The new observations turned up a cavity close to the star and 2 gaps further out, which were obscured in the earlier observations, suggesting that MP-MUS may not be alone after all. At the same time, Miguel Vioque, a researcher at the European Southern Observatory, was uncovering another piece of the puzzle. Discover the latest in science, tech, and space, with over 100,000 subscribers, who rely on phys.org for daily insights. Email. My first reaction was that I must have made a mistake in my calculations, because MP-MUS was known to have a featureless disk, said Vioque. Using a combination of the Gaia and ALMA observations along with some computer modeling, our modeling work showed that if you put a giant planet inside the newfound cavity, You can also explain the Gaia signal, said Rebus. This is the first time an exoplanet embedded in a protoplanetary disk has been indirectly discovered in this way by combining precise star movement data from the Gaia with deep observations of the disk. We think this might be one of the reasons why it's hard to detect young planets in protoplanetary disks. Rebus says that upcoming upgrades to ALMA, as well as future telescopes, such as the next generation Very Large Array More Information, Young Gas Giant, and hidden substructures in a protoplanetary disk. Nature Astronomy. Journal information. Nature Astronomy provided by University of Cambridge.